To really understand what our machine learning algorithms are doing, we'd like to have interpretability tools. Unfortunately, interpretability is still in its infancy. And I think that adversarial machine learning can show some of the ways that the interpretability tools can be improved. A lot of the time, we see that people working in the interpretability literature and the adversarial machine learning literature are asking more or less the same question, such as, how does this model work? We find that people who build interpretability tools often produce images like the ones shown on the right, where we say that a cat is classified as a cat because of the cat pixels, and a dog is classified as a dog because of the dog pixels. This is a very nice result, and it seems very reassuring. But unfortunately, people working in adversarial machine learning for security purposes who do security audits often find, such as the image of the panda on the upper right, that machine learning algorithms work for very mysterious and, well, relatively broken ways, that they tend to get a lot of wrong results in ways that the current interpretability tools would not predict. I think these two research communities should work together more in order to produce more effective interpretability tools that can discover when machine learning algorithms are working in incorrect and counterintuitive ways. I also think that as adversarial machine learning improves and we make our models more robust, they'll be easier to interpret. Right now, they make a lot of mistakes and use a lot of messy decision rules. But in the future, as they become more robust, they might start to make better predictions. Here on the left, I show what happens if we load an image of a 9 into a model that is not very adversarially robust, and we start to adversarially perturb it to turn it into the different classes. As we read through the image left to right, top to bottom, everywhere that you see a yellow box, it's been turned into a different digit class. So at the end of the first row, there's a yellow box around the 9. That's actually classified as a 0 with high confidence. And in the second row, there's another yellow box. There it is classified as a 1. And then the next yellow boxes are a 2, a 3, a 4, and so on. The only one that's actually correct is the 9 in the lower right. And the only reason that that actually looks like a 9 is that we started the whole process with a 9. So when we have a relatively vulnerable model, in this case, it's just a shallow linear softmax classifier, it's actually very hard to interpret what the model does because it makes so many counterintuitive mistakes. And it would be hard for an interpretability tool to explain to a human all these different ways that even a relatively simple linear model can go wrong. On the right, I show what happens when we take an adversarially robust model. It's not perfectly robust, but it's a lot better than the linear model. This one is also a shallow model based on RBF units. And on this relatively robust model, we see that as we optimize the input, we actually get recognizable examples of each of the different digit classes. This seems much more amenable to interpretability analysis. On the left, we need to summarize all of these bizarre and counterintuitive failures. On the right, most of what the model does is actually relatively intuitive to a human observer.